Algebra 2, here we are with the unit circle. Alright, we have unit circle based on special right triangles. So rewind to last year's geometry class. Okay, we had a 45-45 isosceles right triangle. Okay, and I use x's, x radical 2. Your teacher might have used leg or side or whatever. Okay, today we're using the unit circle with a radius of 1 unit. That's going to be the hypotenuse. So if the hypotenuse is 1, what are the other two sides? They have to be the same. So I'm going to put in x squared plus x squared equals 1 squared. That's going to give me 2x squareds equals 1. 1 squared is 1. Divide by 2, x squared equals a half. Square root x equals, square root of 1 on the top is 1. Square root of 2 on the bottom is radical 2. Can't stop with the radical in our final answer. And we'll have radical 2 over regular 2. So the side lengths of our 45, 45, 90, radical 2 over 2. All right. The other special right triangle that we have is a 30, 60, 90. And again, your teacher might have used S for side or L for leg. I just use x radical 3, 2x. Again, the hypotenuse is going to be the radius in our unit circle down below. So if the hypotenuse is 1 unit, and the 1 is on the hypotenuse side, 1 is 2x. That means x equals 1/2. So the short side is a half, and the long leg is a half times radical 3, or radical 3 over regular 2. Okay, what are we going to use these for? Okay, think about what your sine, cosine, and tangent stuff is made up of. Okay, sine of 30 would have been opposite over hypotenuse. Well, now because our hypotenuse is 1 unit on both of these, it's really just the opposite. Or cosine would be the adjacent. So these are your trigonometry values for those functions at those angles. So we're going to have a big circle of some of the more basic trigonometry values that you might run across. Okay, the good news is it looks like a lot of stuff, but you're going to be using the same like 5 spots over and over and over and over again. So starting us off at 0 degrees. 0 degrees, if our radius is 1 unit, we're 1 over and no up. 1, 0. Okay, then we're going to be using our 30, 45, and 60 degrees. The reason I like this particular unit circle is because it's kind of drawn to scale, so you can see those bigger gaps are going to be your 30-degree gaps, and then your smaller gaps are going to be your 15-degree gaps. So it's going to be 30, 45, 60, and a big gap, 90. Okay, so 30 degrees. You can kind of see the triangle right there. The coordinates for that dot, is it more over? Is the over part bigger or the up part bigger? Okay, the over part is bigger, so that means we're over radical 3 over 2, and we're up a half. Okay, 45, 45, piece of cake, the radical 2 over 2 for both spots. $60. Now we're not very far over and we're a lot more up. So now the x is going to be the short one, and the y coordinate is going to be the long one. So we're going to flip-flop that, and we're going to have half, comma, radical 3 over 2. And when we get to 90 degrees, we're not any over, so 0 left and right, and all up. 0, 1. So if we wanted to know cosine, well, I didn't tell you which one's which. These are all going to be of the form cosine, comma, sine. Okay, the cosine value is the x-coordinate, and the sine value is the y-coordinate. So if we wanted to do cosine of 60 degrees, cosine is a half. Sine of 60 degrees would be the y-coordinate, sine of 60 degrees, radical 3 over 2, like 0.866. Okay, so that's why this is so useful. You see what we missed? What was that other ring of blanks before? Radians. 0 degrees would be 0 radians. That's the easy one. Okay, hopefully you remember some of these from your lesson yesterday or last class on converting radians and degrees back and forth. Otherwise, we're going to need to remember our conversion. Degrees to radians is going to be times pi over 180. Reduce your degrees and put the pi on top. So 30 degrees times pi over 180 would reduce to pi over 6. 45 degrees should be pi over 4. 60 degrees is pi over 3. And 90 degrees is pi over 2. Now that was a lot. Okay, the good news is you don't have to do all that thinking again. This is all going to flip over. Okay, so continuing with our degrees, big jumps are 30, so 60, 90, big jump 120, little jump 135, 150, 180. Okay, now here's what we can do with our radians. I'm going to try to share some secrets. The pi over 3's are by the y-axis. Okay, the pi over 4's are always going to be in the middle, and they're always going to be odd pi over 4's. 1 pi over 4. 2 pi over 4 would be 90 degrees, and 2 pi over 4 would reduce to pi over 2. And then it's going to be 3 pi over 4. 4 pi over 4, 5 pi over 4. So the even pi over 4's reduce, and they're going to be the ones on the axis lines. The odd pi over 4's are going to be in the middle. And then the pi over 6's are going to be next to the x-axis. Okay? So 60 degrees times 2 would be 120 degrees. Pi over 3 times 2 is going to be 2 pi over 3. We said the middle ones are going to be the odd pi over 4, so this is 3 pi over 4. Okay, the pi over 6's you have to think about a little bit. So at 0, and this is up 1 to pi over 6. Straight across, 180 degrees is 1 pi. Now if we're thinking in terms of pi over 6's, that would be 6 pi over 6. Up 1 would be 1 less, that's 5 pi over 6. That's kind of tough to think about. Okay, the points are even easier. In quadrant 1, everything is positive, positive. In quadrant 2, these all flip over, and the front numbers are going to be negative. So this is going to be negative 1/2 positive radical 3 over 2, negative radical 2 over 2, radical 2 over 2, negative radical 3 over 2, 1/2, and negative 1, 0. Okay, I'm going to fill in the degrees. Yeah, you know how to fill in the degrees. The big jumps are 30 degrees. Try to follow the pattern here for your radians, and then even your coordinates on the outside. Remember, on quadrant 3, all our points are negative, comma, negative. All right, go ahead and push pause and try to fill in this piece of the puzzle. All right, let's see how we did. So big gaps are 30, so we got 210, 225, 240. Let's go all the way down here too. 270. So this one was pi over 6. Okay, 5 pi over 6, 6 pi over 6, 7 pi over 6. Odd pi over 4, 1, 3, 5. Okay, 1 pi over 3, 2 pi over 3, 3 pi over 3 would be a full pi. So this is going to be 4 pi over 3. And the next one by the y-axis later is going to be 5 pi over 3. 0, half, 1, 1 and a half. 3 pi over 2. And then your coordinates, these are just all negatives. So negative radical 3 over 2, negative a half, negative radical 2 over 2's, negative on both of them, half, and negative radical 3 over 2, 0, negative 1. Alright, turn it around, keep it going up. Pi over 3, so 4 pi over 3, 5 pi over 3. Odd pi over 4, odd pi over 4. This one's going to be the 7 pi over 4. Okay? This spot can be kind of tricky. This is meant to be 360 and 2 pi. We'll take care of that just so that's not confusing you. Up a pi over 6, down a pi over 6. That is 11 pi over 6. 2 pi would have been 12 pi over 6. In our degrees, 300, 315, 330. Okay, reflecting our points over. Quadrant 4, we have positive comma negatives. So that's a half, negative radical 3 over 2, radical 2 over 2, negative radical 2 over 2, and positive radical 3 over 2, negative a half. Okay, so that is the full unit circle. Alright? So some things we can be doing. We need to be practicing this a lot to get this kind of cemented in our brain. Again, I like this unit circle because then you can at least kind of fall back to the degrees and count big jumps are 30, little jumps are 15, big jumps are 30, 15s, okay? And then if you have to, you could go back and do like degrees to radians. Okay? Some shortcuts for the radians. Okay, you got the 0 and full, 0 pi and 1 full pi, and then back to 2 pi. 1 over 2, 3 over 2. Half, 1 and a half. Okay, those are the axes. Count by halves. 0, half, 1, 1 and a half, 2. Pi over 6s are next to the x-axis. Pi over 3s are next to the y-axis. Odd pi over 4s are in the middle. Okay? Another little trick that really isn't good for like time-wise, but okay, if you cover up vertically, if you cover up the halves, cover up the left half, the right half, 1 pi over 3, 5 pi over 3. Adds up to 6 pi over 3, 2 pi. 1 and 7 pi over 4, 8 pi over 4, 2 pi. 12 pi over 6, 2 pi. You can do the same thing over here. 6 pi over 3 for 2 pi. Okay, and all these will add up and reduce to 2 pi. Now, that does not work covering up and down. Well, what are we going to do with this? Okay, we talked about these are all sine and cosine stuff. Okay, so the back side of your notes is another one to practice on. Okay, and then your homework is yet another one to practice on. And then the back side of that, you're going to finally use your unit circle to complete the following. Okay, I would really expect the first day you'll probably have to do some flipping. Okay, and then maybe by the second or third day, we might not have to flip for all of them. It's like sine of pi over 4. We're going to look for pi over 4, radical 2 over 2, comma radical 2 over 2. Sine is the y-coordinate, radical 2 over 2. Hopefully we get to the point where we don't have to look at it. I sometimes like to quick sketch it. Okay, pi over 4 is here, and then that triggers my memory of like what that is. Boom, radical 2 over 2, radical 2 over 2. Sine's the second one. Got it. Okay, let's go down to cosine 240 degrees. 240 degrees. Boom. Cosine is the x-coordinate. Negative a half. Okay? The fun ones are tangent, because tangent equals sine over cosine, or in our unit circle, that would be y over x. So tangent at 150, y over x is going to be half over negative radical 3 over 2. Okay, fraction over fraction. You're going to multiply by the reciprocal. Okay, so those 2's cancel out, and we'll have 1 over negative radical 3. Okay, we don't want to stop with the radical on the bottom. So we'll have radical 3. I'm going to move the negative to the top, over regular 3. There it is. Okay? Now, we talked about some of the patterns here on the unit circle. Okay? You can listen to me tell you about those all day long, and you're not going to be able to know it until you start actually doing it. Okay? You're going to have to do it a bunch of times, and then you'll get better at it. We want to get to the point where we can kind of do this from memory. Okay? You're not going to get a unit circle on the quiz or the test. You might get a blank one, and then you could fill it in, or worst case, you could sketch your own and fill it in. Alright, thanks for watching. Good luck out there, and have fun with your unit circles.